All right, here we have a triangle. This is not necessarily a right triangle. I don't know, it kind of actually looks like a right triangle, doesn't it? That angle at the top. Let's do that so it really doesn't look like a right triangle. Okay, so that doesn't look like a right triangle. So what we're going to do is we are going to try to solve for, they're going to give you a few things here, and we're going to solve for some missing sides, missing angles, but we're not going to do it with our regular trig functions. I showed you that video yesterday, and what was the thing we learned yesterday? It was called the law of sines. All right. So watch. Let's label this thing. If I call this A, B, C, we've talked about this quite a bit. If this is angle A, which side would we call side A?
Side A.
Which one? Which one of these sides would be side A? The one opposite, exactly. Okay, so we make that a lowercase. Lowercase represents the length of the side. Now, I could have called it side BC, couldn't I? But it's just a lot easier saying angle A is opposite side A. Wouldn't you agree? All right, so that's how we do that. If this is angle B right here, then what would this side be right here? It'd be little b, right? And if this is angle C, this would be side C, which would be a little bit smaller. All right, everybody with me on that? Okay, that's one of the law of sines, not all sine. All right, so anyway, this this triangle really helps you when you're learning the law of sines. So do you remember what the little formula was? It's actually kind of easy, isn't it? It's the sine of angle A, right, over side A equals the sine of angle B over side. Oh, why did I put C? I'm getting ahead of myself. B equals the sine of what? Angle C over side C. Now sometimes the angle C and the side C kind of look the same, right? Because lowercase, uppercase, just one's bigger than the other. These definitely look different, but just make that smaller than that. Now, are we going to use all three at the same time?
No.
Not really. Okay, if they wanted to, they could have just said this, couldn't they? All right, you could have just written it like this if you wanted to. Now, technically, it's all three of them because you could do that with all three of these sides. But really, in the long run, what we're going to do is we're just going to pair them up. These are just ratios between the angle and the sides. All right, and you could throw in C if you wanted to, but you wouldn't use all three at the same time. You only use two at the same time. So what we're doing is this. If I know three of these four things, if I know, let's say, this angle and one side, I should be able to find the other side. You see it? What if I knew just one angle and I didn't know this one, but I knew these three things, these two sides and this angle, I didn't know this? You should be able to solve for that. Okay, you with me on that? So if you know three of those four things, you should be able to solve for that missing part. That's with a non-right triangle. Remember, law of sines is used when we do not have a right triangle. If you had a right triangle and you knew an angle and a side, then I wouldn't use a law of sines. Would it still work? Yes, it would. But it's a little bit more to go through. I think using the regular trig functions, sine, cosine, tangent, I think that's a lot easier on a right triangle than going through the law of sines. All right? I had kids in my, the honors class on the test. It's a right triangle. Specifically, it's a right triangle with a little perpendicular mark, little right angle mark thing on there. And they're trying to use the law of sines and law of cosines to find the missing stuff. Okay, that's a lot more difficult than just using the regular sine, cosine, tangent. Everybody hear me on that? So let's make sure that if it's a right triangle, what do you use if you have a right triangle to find missing sides, missing angles? You're using the, well, if you had two sides, but what are you going to use? If I had a side and an angle, use what? The trig, what? Functions. That's what we call them. What are the trig functions? Sine, cosine, tangent. Okay? Those are our trig functions. So if you had a right triangle, you use the trig functions. If you don't have a right triangle, you can't use the trig functions. You got it? So if you have a non-right triangle, what did they call that in the video yesterday? Oblique, right. I probably won't call it that. We'll just say if it's a non-right triangle, then it's use the law of sines. Now, there are times when you can't even use the law of sines. You got to use something else. What do you think that's called? Law of cosines. Okay, we just mentioned it yesterday. We didn't really go over it, but I might mention it today. We'll see how it goes. All right. So here we go. Let's do an example with this and see how we use this. Let me use the same triangle. Oops, I don't want to do that yet. All right, let's put this triangle right here. And I tell you what, let's not use this triangle. Now that I said that, I want to use I'm going to use the one right from the book. Yeah. All right, so it kind of looks like that, kind of. And let's put some stuff in here. They say this is, let's do it in a different color here. Let's get some purple. So let's say this is 97 degrees, that angle right there. This is 21 degrees down here. This is 16, and this is x. You with me so far?
Yes.
All right. Yeah, I mean, what's not to get? All I did was just put stuff in a triangle, right? Let me give myself some room to write here. Now, what are we trying to do? We're trying to solve for x, correct? Now, using the law of sines, let's go back to this again. Using the law of sines right here, I'm going to have to know 3 of these 4 things. Remember I said that? So I'm going to at least have to know one angle and a side that's opposite that angle. Everybody see that? So looking at the picture, I need to see that I have one angle and a side opposite that angle. I'm going to have to at least know that. Then I can know what? Either one of the sides and find the angle, or know one of the angles and find the missing side. Everybody see that? All right, so let's go down to this one and see if we can figure out what we're going to use here. Oh, by the way, let me mention this. They said this on the, they did say this on the video. They said you could write it like this, or you could write it like this. Remember that? To tell you the truth, I'm going to look to see what I'm trying to solve for. If I'm trying to solve for one of the sides, I'm going to write it like this. Why would I write it like this if I want to find one of the sides? Well, because the side would be on top. Okay, I think it's a little easier. I think the algebra is a little easier if what you're trying to solve for. Okay, I think whatever you're trying to solve for, if it's on the top, it's a little easier. If I'm trying to find an angle using the law of sines, I'll do it this way. Does it make sense? So if I'm trying to find an angle, I'll write it like this. If I'm trying to find a what? A side, I'll write it like this. It just makes it a little easier. You don't have to. I'm just trying to help you out. Isn't that nice of me? Okay. So let's go back to this. Yeah, I know. All right. So what are we trying to solve for? Trying to find a side, aren't we? So we're going to write it with the side on the top, aren't we? So we're going to write a over sine of a equals b over sine of b, or whatever letters they have. I didn't even label any of these angles, did I? But let's just put the numbers in. Watch. I want to solve for x, so I'm going to put x over what? Do I know the angle opposite this x? Yeah, it's 21. So I'm going to put what? Not just 21, but the sine of 21, right? The sine of 21 degrees. Now, do I know the other angle and the side opposite that angle? Yeah. Look, I know an angle, don't I? And I know the side opposite that angle. Remember, we have to know 3 of those 4 things, don't we? All right, so I've got an angle, and I've got an angle opposite a side. So that's what I need. So what am I going to put on top then? If I put the side on top, what am I going to have to put over on top here? I'm going to put the 16 on top here, and then the sine of what? The angle that's opposite 16, which is 97. I'll stop and let you digest that for a second.
And what is this help? This is helping us solve it for x.
Solve for x with a non-right triangle. See, we wouldn't have been able to do this before today. There's no way we would have been able to find this. I couldn't just use sine, cosine, tangent, because there is no hypotenuse, right? Because there's no hypotenuse, because there's no right angle.
So you take whichever variable you're trying to figure out and put it on top.
If it's the side, yeah. If it's one of the lengths of the sides, I would put that on top. Find the angle that's opposite. Right? And you would have to know that. If they didn't tell you the angle opposite this, you wouldn't be able to do it. Okay? But if they tell you, yeah, if they tell you the angle opposite this x, you put it on the bottom of the x. Okay? These have to be opposite each other. That's why they're the same letters. Did you notice? Yes. Angle A, side A. They have to be opposite each other. Angle B, side B. They have to be opposite. Okay? Yes. How do you solve it? You could cross multiply, but watch this. I made this a little easier for you by making sure that you put the x on the top. I'm trying to solve for x. It's already on the top. So what do I have to get rid of to get x by itself? Sine of 21. Now how can I get rid of that sine of 21? It's being divided, isn't it? Just multiply by the sine of 21. And the sine of 21 is just a number that you can find on your calculator. Right? So I multiply this by the sine of 21. What do I do over here? Multiply that by the sine of 21. Okay, Amber, you getting all this? We're doing brand new stuff that you've never seen before, and you're going to have your head on the desk. I don't know if, I think listening and watching would be better, don't you? Okay, put your head back down then. It's fine with me. All right, if that's the way you want to be, that's fine. All right, so watch. This cancels out. All right, and what do we have over here? We have x. And then what's this? What do we do with all that? Put it in the calculator. Absolutely right. Okay, let's pay attention. Got my calculator. Now I'm just going to put this in the calculator. Now watch. On this calculator, I'm going to go exactly the way it's written.
16
I'll do this. I'll go 16. I don't even have to hit times. On this calculator, I just put sine of 21. Sine of 21. Now, on your TI-30, what you would have to do is you'd have to hit... What I would do is this. If I had the TI-30, I would go 21 sine times 16, and then equals. Okay? And then divided by what? Not sine of 97, but 97 sine. Then hit equals again, and then you'll get your answer. Did you hear what I said? So if you have a TI-30, do it like this. Punch them in right now, this second. Hit 21 sine times 16 equals. It's not much to remember. You just know that you put the number in, then you put the function.
But not for every calculator.
For that calculator. I use that calculator for years and years. It's still my favorite calculator to use, to tell you the truth. I don't know. We'll do it on here and we'll see. But watch. It's not that hard. On that TI-30XA, just XA, right? Yeah, you hit the number first, then you hit the function, okay? So you hit 21, then you hit sine, then you have to hit times 16. I always hit equals. I don't even know if you have to, because the divide might do the equals. But I always hit equals. Then I hit divide, and then I hit, what? 97 sine. Now that's not your answer. You'll get a decimal there. Then you got to hit equals so it does that division. After you hit equals, you should get the same number that I'm going to get right here. Okay?
Your calculator turns off when you're
I guess it's saving batteries, even though it's not using batteries, I guess. Okay, so let's when you do what? 16 sine of 21. What I'm going to do is I'm going to hit. I'll tell you what. You know what I should do? Let's clear this. I don't want to make this too confusing, but watch. I'm going to put a parentheses around this, okay? Because the calculator, if I don't put a parentheses around this, it's probably going to think the sine of 21 divided by 97, but I want 16 times the sine of 21. That whole thing divided by the sine of 97. So I have a feeling it might not work if I don't do that. So watch. Let's put a parentheses, and then let's do this now. 16 sine of 21. Now watch what I do though. I close that parentheses, close that one, right? Then I got to have another one to close that first one. Everybody with me? So it's taking the whole thing. Now it's dividing it by what? Sine of 97. So I hit sine of 97, and this should give me the same answer that you got. Is that what you got? Okay, we'll call it 8. Is that all right? So it's 5.8.
5.8. I get that.
I got 5.8.
Okay, first of all, are you in degrees? Are you in degrees? Okay, but listen, we just went through this whole thing. You got to go to mode, make sure it says degrees. Is it in degrees? Okay, if it's in degrees, then do this. Did you put one parentheses first? Did you start off with a parentheses? And then 16 sine 21, 2 parentheses, right? Divided by sine of 97, close that parentheses, hit equals or enter, and then you should get that number. It's all up there for you. Hey, wait. Joel's talking. Okay. Yeah, it might work, but I'm just being careful. Yeah, you're right. I mean, if you don't put that parentheses and that parentheses, it still might work. And Joelle said she tried it, and it does. But I don't know. I just like to be careful with that. Did you get it? Yes, you did. Good. Okay, good. All right, so there you go. That's how you do that. So that's that side right there. Let's see what they do. Do they ask you to solve for everything? No, on that problem, that's all they ask you to solve for.
What do you round to?
Whatever they tell you. We'll just go 5.8. Make sure you get that. Just because you're using a calculator doesn't mean it's that easy. All right, you got to make sure you practice. You've got to practice using your calculator on this stuff. All right, it used to be when you're a little kid, you see a problem, you just punch it in, you get an answer, right? You didn't have to practice that much. All right, but this is a little more difficult, isn't it? So you're going to have to make sure you know how your calculator works. Okay, you need to get one. Really, go to Walmart and get $10. Walmart, you can get a nice scientific calculator. There you go. Okay. Let's try another triangle. This time, this is going to be a little bit trickier. But you know about that inverse stuff, right? Well, let's.
No, that's
I'll give you. That's what the homework's for.
That's homework.
What is it with all the
No,
teachers
'cause that's
this year
the
giving
question
homework
that
to the weekend?
Well, you go to YouTube.
Well, I don't have homework.
All right, here we go. Let's take a look at this. Here we go. Shh, guys, settle down.
See, now you ain't calling up. That's why you starting.
All right, here we go. You ready? All right, what are we trying to solve for this time? An angle. So, remember we're going to put on top now? Just to make it easier for you, we're going to put the angle, right? So, we don't know what it is, so we're going to put what? The sine of x. We'll put that on the top this time. Right? So whatever you're trying to solve for, I would put that on top. Just makes things a little easier for you. So the sine of x over what? It's got to be 10. Why? Because it's got to be the side opposite the angle. Very good. You got it. Okay. Now, the thing is, you have to know the other angle and the opposite side of the other angle, don't you? And we do, right? They give it to us. This is 45 and this is 8. So what am I going to put on top? Sine of 48, right? Or 45, sorry. It's 8 and I said 48. All right, sine of 45 over what? The side that's opposite that angle, right? This side has to be opposite this angle, right? Is it? 10 opposite x? Yes, it is. Is 8 opposite 45? Yes, it is. All right, so we're good to go. Now, just because this is 45, does that mean this is a 45, 45, 90 triangle? No, it's not, okay? Because I don't know either one of the other angles, right? So I can't make any assumptions about that. And the reason I say that is because people do. They say, Mr. Hammer, it's 45 degree, it must be 45, 45, 90. It doesn't mean it is. Now it could be, but we don't know. We just don't know. So what are we going to do to solve for x here? Yeah, exactly. It's kind of the same step as we did before, isn't it? I want to get x by itself, don't I? So what do I do with that 10? I multiply by 10. I think this way is a lot easier. Putting what you're trying to solve for on top, and all you got to do is multiply by that bottom to get rid of it. I think that's a lot easier. And then multiply this side by 10. I tell you what, instead of putting like a times 10 here, when you have a sine, we usually put the 10 right in front. That makes it a little bit nicer. Did you see what I just did right there? That means I multiplied that by 10. So that 10 cancels out. And so let's see what we get now. Now, we didn't get x by itself just yet, have we?
No.
It's the sine of x equals 10 times the sine of 45 over 8. Now, we've done this before. This shouldn't be new to you. I want to get x by itself, but it's the sine of x. So somebody... Negative thingy. The inverse, right. It's the inverse. The inverse. But we do, I know what you mean by the negative thingy. It means you take the sine to the negative what? First. So that'll get rid of this. So x equals, it's not just this though, is it? Don't just put this in your calculator. It's what? It's the inverse sine of all this stuff.
This work is good.
No, it's not.
That's not hard at all.
Attention is really not that hard.
You're right, I agree.
Caps.
Come on. Here we go. We've done this before, right? It's not brand new to you. So if I want to get rid of a sine, how do I get rid of a sine? I don't divide by it. I take the inverse of it. What's an inverse look like? It looks like to the negative first power. It's not that big of a deal, right? We've dealt with that plenty before. So now this is what you have to put into a calculator. Looks a little bit crazy, but let's see what we can do with this. What I'm going to do is this. I'm going to do all the stuff in the parentheses first. And then I'm going to take that answer, and then I'm going to take the inverse sine of it, second function sine. Is that all right? I think you could do it all in one shot if you wanted to, but I think it's a little easier if you do that. So let's do all the stuff that's in the parentheses. So let's do that. It's going to be 10, sine of 45, right? I think I should be able, Joey, you said it would be fine, right? If we just hit divided by.
It is.
Okay, and then 8, and then let's get that number. So that right there is 0.88388, blah, blah, blah. But what do I do with that? That's not my answer. I have to do what to it?
And multiply it by the
Well, not multiply it, but take the
negative energy.
inverse. Take the inverse. Well, at least integer starts with an I. You're close, okay? It's the inverse of the sine. So watch. I'm going to take this. I'm going to take second function what? Sine of this answer. Now, I don't have to re-put that answer in there. On this calculator, I can hit second function answer. See what it does? Where the minus button. Now, so second function answer. I know, but look, yours is actually easier. That's why I like the 30 better than this for this kind of stuff. Because look, you put all this stuff in your regular calculator, you get an answer, then all you got to do is hit inverse or second function sine, and it'll give you your answer. All right, so this actually is a little bit more involved. So you hit equals, and there it is.
The first time I just put everything in at once. I did it.
Yeah.
Inverse.
Yeah, right. You could do it all in one shot. Exactly right.
So I did the first time.
Okay, watch. Joelle says she did this. She did. Let me just show you. You can do it all in one shot. You could hit sine of negative, right? You could say inverse sine, and then, did you put two parentheses, or you just kept that parentheses right there? Okay, and then you go 10 sine of 45. I don't know. I like to close that one, though, right?
Divide by 8.
And then I would, yep, and then hit divide by 8. Then I would close that one. Did you close that one?
No.
You didn't even close that one? Okay. Yeah, so the calculator is, I guess, pretty smart. It kind of knows what you're doing. But I don't know. I like to be careful and put my parentheses here, and then there it is. Same exact answer, isn't it? All right. Makes sense? So you could do it all in one shot instead of doing that answer thing. Now, how would you do this on a TI-30? Look, what I would do is this. I'd hit 45 sine times 10 equals... Okay, I don't even know if you have to put equals. You might not have to, but I do. Just be careful. I hit equals, and then I hit divide, 8, hit equals again, and then second function sine, and it'll give you your answer. You should get the same exact answer. What was it again? 62.1, right? So x, right there, is 62.1 degrees. Now look, if you know this angle right here, you should be able to find this pretty easy. How would you find this angle real easy without using... That's right. Take them from 180.
What if, like, you do this sine -1 before?
On which calculator, though? On this calculator, you can do it. And I just did it right there. I just showed you. But if you use the TI-30, no, you got to do the stuff first. On that TI-30XA, you have to do this stuff first, and then at the very end, hit second function sine. All right, so don't hit second function sine first, because what it's thinking, it has a 0 already on there. It's thinking the inverse sine of 0, and that's not what you're trying to do. Okay. All right. So how could we find this? You can just do this. You can just go. Now people are saying add them up, but watch what I would do. I would just go 180 minus what? 45 minus 62.1. And that's that angle right there. So that's 72.9. Now if you wanted to, look, you could find this side right here, couldn't you? We'll call it y. How could you do that? Well, look, you know the angle opposite this, don't you? So you could use, and you know this angle and the side opposite that angle right there. So you could use law of sines again, couldn't you? We got a couple minutes. Let's do that.
Awesome.
Okay, so look. Because they might say solve the triangle. What does it mean by solve the triangle?
Find everything.
Find everything. So let's do that. So this is the one thing that's missing. Let's find it. All right, I don't think they do that in the book. Nope, but that's okay. We'll do it for fun, okay? So look, let's take a look. We're solving for y, so y is going to be on the top. Over what? The sine of 72.9 equals, now you got to find another. Now you could use this one right here, right? Because there's a side and there's an angle opposite. You know it now, don't you? Okay, but I'm going to stick with the original one that they give us. So I'm going to put what on top now? If the y is on top over here, what's going to be on top over here? 8 over
Sine
sine of 45. Okay. All right, so I've set it up. I'm done with my triangle now. Now I got to solve for y. Now how do I solve for y? Multiply it by the sine of 72.9, okay, over 1. Multiply this by the sine of 72.9. That cancels, that cancels. You with me? So now y equals all this. So basically, just stick this into a calculator, and you've got your answer. So let's try it. I mean, put it in the calculator is, you know, part of the deal too. It's not always quite that easy. So here we go. Watch on this calculator. What do? I go 8 sine of 72.9. I'll close that. Divided by the sine of 45. Okay, there it is. There it is. It's 10.8. Remember what that guy on that video said yesterday? There was like a kind of a way to check a little bit.
If the big one is
Right, so that's 10.8. So what's the longest side? 10.8. Okay, is that the biggest angle?
Yes.
Yes, it is. Okay, look, what's the smallest angle?
45.
45. Is that the smallest side? Yeah. Now, that's not a guarantee that you did it right, but at least you know you're kind of on the right track, okay?
You don't need to check what you missed on me.
All right. Okay. I'm going to have to run and make a copy. I forgot to make a copy of the worksheet. But we're going to do, we'll probably only do about half of it because we didn't do the law cosines today. Are you listening? So we're going to do worksheet 8.6, but we're just going to do the problems with the law of sines. Give me a second. I'll be right back.